Hi everyone, so as promised, here is an explanation of a simultaneous equations problem where you have a linear equation and a quadratic. So just to explain the concept of what we're looking at, let's just say we have a pair of axes, your usual x-axis and y-axis. Then if I drew a quadratic equation as a graph, could be a frowny graph, but there's a smiley one for us. And then if I draw a linear equation, it would be a straight line. So it would look like this. So what simultaneous equations using a linear and quadratic is looking for is where the two lines intersect, but because it's a quadratic, we're going to in fact end up with 2 points of intersection. So we would expect to have two solutions. Okay, so how do we go about doing it? So let's take a look at the example from the study guide, which is the simultaneous equations are change colour, y equals x squared minus 3x plus 4, and then we have y minus x equals 1. Okay, so probably the best way to do simultaneous equations in this format is to make y the subject of the equation, or one of them, and then substitute into the second equation. So we've got equation 1 and equation 2 here, but if you have a look at equation 1, y is already the subject of the equation. So what we're going to do is we're simply going to take what y is equal to, x squared minus 3x plus 4, and substitute it into the second equation. So we say substitute x squared minus 3x plus 4 for y into the second equation. What do we have then? So instead of y, we write x squared minus 3x plus 4, and then we have that minus x at the end, and it equals 1. Now we're going to simplify that. X squared minus 3x minus x is minus 4x plus 4 equals 1. And now we are going to solve that. So what have we got? We've got, that's a perfect square, isn't it? So it's x minus 2 all squared is equal to 1. Now from this point, we can square root both sides, but when you do so, note that you've got x minus 2 on the left-hand side, but you've got plus or minus 1 on the right-hand side. So at this point, we need to split the equation up. So I'll just write that on the next page. Before I move on to the next slide, I should point out that alternatively, and probably maybe I should have, I could have gone x squared minus 3x, minus 3x plus 4 minus x equals 1, simplified x squared minus 4x plus 4 equals 1, subtract 1 from both sides to get it into general form of the quadratic, x squared minus 4x plus 3 equals 0, and then factorise that to x minus 3, x minus 1 equals 0, and then solve. And again, I'll get two solutions out of that, x equals 3 and x equals 1. But if I did factorise like I have here, then you'll see that I'll get exactly the same solution set as you would imagine. So therefore, x minus 2 is equal to 1 and x is equal to 3, or x minus 2 equals negative 1 and x equals positive 1. Okay, just to go back a slide. Okay, so there we have x equals 3 and x equals 1. What we do now is we substitute 3 and 1 into the original equations and go from there. So we had y minus x equals 1. So that's on the next page. We had y minus x is equal to 1, and we worked out that x equals 3. Just put this on the side so we can remember x equals 3 or x equals 1 as our solution. So we simply substitute x equals 3 and x equals 1 into this equation to work out what y is. So we have y minus 3 is equal to 1, therefore y is equal to 4. And on the side here, I'm just going to write the coordinates that I've worked out. So it was 3, 4. And then we do the same thing with the other value. So we have 4 y minus 1 equals 1. therefore y is equal to 2. And so we've got 1, 2. So if we did draw the quadratic, we would have the line intersecting at 2 points, and those 2 points would be 3, 4 and 1, 2. Hopefully all that makes sense.